Okay, this was a long, rambling question, number 5 on page 481, but it really comes down to this area right here is all I'm concerned with. Now it says describe the shape, center, and spread of the sampling distribution. Well, I'm just going to assume that the center is the same as what we got for our sample mean, which is 280. So that's what we call a point estimate, and we're using a sample mean as our point estimator. So point estimate 280, that's our center. We're going to have a different standard deviation because we're going to get the standard deviation of the sample mean, which is going to be, 60, the old standard deviation, divided by the square root of the sample size, like that. And I got, for that, 2.07. Now, for some reason in the book, I think they rounded up to 2.1 here. So let's just go with that, what the book does. So it's 2.1. Now, let's go to letter B. So letter B says, sketch the sampling distribution of our sample mean. Mark its mean and values of 1, 2, and 3 standard deviations on either side of the mean. So here it is. This is what we're going to assume the middle is, and 2.1, 2.1, 2.1. 3 of them on either side. Okay, so there's that. So letter C says, according to the 68, 95, 99.7 rule, so remember, 68% of our data is contained within 1 standard deviation on either side. 95 is contained within 2 standard deviations of either side. So 95% of our data is inside this area here. And then 99.7 is within 3 standard deviations on either side of the mean, if you don't remember that rule. Okay, so it says about 95% of all values of x lie within the distance of m. M is our margin of error. Okay, so the sampling distribution. What is M? Okay, so what we're going to do is we're going to say, well, it's 2 standard deviations. 95% is 2 standard deviations. So it's plus or minus 4.2. Okay. So you might have been a little bit confused on that. So the margin of error, we're going to call that M, and it's going to be plus or minus 4.2 on either side of our middle here. Okay, so really kind of assuming that our confidence interval is going to lie somewhere between these two numbers. So we're giving ourselves an interval, right? A confidence interval. We are confident that it's within this interval. Okay, let's go to letter D. So letter D is talking about that confidence interval. See, here's our average, x bar, plus or minus 4.2 on either side of that middle. So, and when we use this rule here, if we go 2 standard deviations on either side, we're saying we're 95% confident that our true average is somewhere in between there. It might not be exactly 280, but it's somewhere in between these two numbers. Confidence interval. There we go. So number 6 is kind of the same way, except you might have been a little bit confused when they're like, you don't know what the mean is. Well, just put it right there. Here's our unknown. This is for the population. We're assuming that our average NOx emission is right here, plus or minus this new standard deviation, just like we did on number 5. So this is what the graph would look like. See if you can answer the rest of the questions for number 6, just like we did on number 5. It's just that we just don't know what that middle value is, and that's okay. We just use that symbol for mu for each of them. Okay, let's go to the next one. Okay, this is for number 7. Now this is a really good picture. This is on page 474, I think. They told you to refer to it. So let's just think about number 5, where the average was 280. That's our middle number here. Okay, our point estimate. And they say pick another number, not 280, that's right in the middle. Some other number, like right here, maybe you would pick, say this is, I don't know, 284, and then plus or minus 4.2 on either side. So it would still, if you minus from that, if this was 284, you would still hit it just barely, because it would go down here 4.2 on either side, so it would just barely nick this side. It would still include that 280 number. But then if you had another number that was much higher, maybe instead of 280, you made it, I don't know, 287. So right here, even if you did plus 4.2 on either side, it wouldn't reach that 280. It would be too high, and it would miss our actual, if this was our actual number, this is the true mean for the entire population. So one of these intervals, adding the margin of error on either side, still captures that true mean, or this one that's on the outside actually misses it. Okay. Anyway, like I said, this is a good picture to kind of try to noodle around with and get some understanding of what this confidence interval is doing. Now, this is talking about like the confidence level, right? We take many different intervals. Some of them are going to capture the true mean. Some of them are not. In fact, how many are going to capture? Well, we're going to assume that around 95% of them will actually hit this true mean for our population, and 5% will not. Okay, so there's that. Let's go to the next one. Actually, I think number 8 is very similar. They just talk about the knocks. Same kind of an idea. They just want you to draw just two intervals. One that hits the true mean, and one that misses it, because it's too far outside. Our margin of error is not wide enough to capture the true mean. Okay, there's that. Okay, number 9. Here we go. Which confidence level do you think we used? Okay, so right here. Remember, confidence level is when we think about if we did this many times, many different confidence intervals, how many of them would actually capture this true mean for a population. Now in this case, I counted them up, there's 25 of them, and out of the 25, 21 of them hit this true mean. Our confidence interval is wide enough to, even this one right here gets our true mean. So you would do this. You would say, well, 21 out of 25 gives us a percentage of, well, 84% of our confidence intervals out of this group, 84% of them hit our true mean. Okay, so which one would we choose from this list? Well, I would have to err on the side of caution and say, well, I think we're at an 80% confidence level for this situation, this picture. Okay, there's that one. Okay, this is number 10. Now look at this. Here is our true mean, whatever it is. That's what that mu stands for, the true mean of the entire population. And we made several guesses as to what the true mean is, and we added and subtracted the margin of error. Now when we did that, every single one of our guesses, when we added and subtracted a margin of error, included the number that actually is the true mean. Well, that's pretty good. Now what would you say is the confidence level for this thing? Well, I would never say it's 100%. In fact, I might not even say it's 99. Just to be safe, I might say it's at least a 95% confidence level. 95% confidence level. Okay, when we look at doing many of these, lots of these confidence intervals, we talk about a confidence level. Okay, that's number 10. Okay, prayer in school. Do you favor an amendment to the Constitution that would allow organized prayer in public schools? Now, they talk about the legitimacy of the poll that they took, the study, and it sounds like it's pretty good. 66% of the sample said yes. Okay, so 66% is our point estimate. Now, we have a 95% confidence level, and our margin of error is 3 percentage points. Okay, let's talk about letter A. Explain what the margin of error means to someone who knows little about statistics. Okay, so the margin of error is really kind of our wiggle room, meaning we're not really sure if it's 66%. We think it's close to 66%, and we're going to say that it's within 3 percentage points. In other words, we think that the actual percentage of people that feel this way is somewhere between probably 63% of the population to 69% of the population. So that's our wiggle room. That's what the margin of error means. Letter B, state and interpret the 95% confidence interval. So the way we do that is we say this. We are 95% confident that the interval from 63% to 69% captures the true proportion of the population that favors an amendment to the Constitution to allow prayer in school. Wow, that's a big sentence, but that's what we have to write. And we're going to get used to writing it just like that. Okay, let's talk about letter C. Interpret the confidence level. So that is, if we were to do this many, many times, maybe we got 66, maybe we got a different number, and we added 3 percentage points on either side. But if we made many different confidence intervals like that, many different confidence intervals, 95% of the confidence intervals that we would make would capture the true mean of, well, actually the true proportion of people that feel that we should amend the Constitution to allow prayer in schools. Again, that's a long sentence, but we have to say it that way. But we will practice. Let's go on. Okay, I'm going to stop there for now and post this video. All right. See you next time.